So just before I get started. I got a water cat. She loves water. She's literally playing in the water right now. She dips her... Oh! She realizes what she did. Like wondering what her evolution after that's gonna be. Oh, this is one I put together yesterday. It's like... So this is the history of language model architectures. So first you had NKOTB, otherwise known as LSTM, New Kids on the Block. Then you have GRU from My Favorite Villain, Gated Recurrent Unit, which we talked about on my last video. What GPT was trying to tell me to do is like, oh, dude, you should upgrade to transformers. And the problem that I see with transformers is that they're not really set up for real-time generation. They have a very big memory. Like in order for them to work really nicely, they've got to scale. They've got to have a lot of data, and that means they have to have a ton of parameters. Probably something like that 43 million or higher, which means that on a computer like mine, it won't be able to do crap. So, what I was thinking of, okay, so let's just go, because okay, here's my problem. I tried out yesterday. I was on Helios, and I stuck my latent dimensions up to 128. I stuck my batch size up. I changed my learning rate on the priors to be slower, and I also trained for higher epochs. So that's my epochs on the. This is my epochs on VAE training, and then this is my epochs on the prior training. Now, the thing that I noticed is like, okay, gosh, we really do not have. So this is another pivot point, right? And this is another thing that I love about coding with GPT is because my ability to pivot is now higher. I'm less attached to the code that I wrote. There is a history of all of that stuff, but at the same time, I'm like, okay, look, I don't really need to know. It's easy as a programmer, right? You spend all this time writing code, and then what happens is you end up getting attached to that code. Like, no, this is my baby, this is my thing, this is whatever. And I started doing it this way, and now I'm stuck in this code base because I didn't spend enough time in exploration, for instance. And I learned something later on, which made me realize that I had to pivot, but it's too late. I'm already so doubled down into my architecture. So I'm not gonna put you through the really horrible where did Helios go? There we are. Okay, so oh no, that's comfy. There we are. So I'm not going to put you through going through watching this or listening to this because it's literally just 10 seconds of a super high-pitched tone that probably people would react to. So that's not... And I was trying to train this on like a whole bunch of samples. These were my data points, right? So what I want to do is, okay, so let's... the thing is okay, right. I never actually got it to output anything besides a simple tone that was a very high frequency. Mismatch of upsampling factor of or number of latent steps. If a decoder transpose convolutions is expecting a certain length of latent input. So first, before I start like pivoting, I'm just gonna go over what I talked to about it last night. Indicates that the model hasn't learned any interesting structure, right? So that makes sense. If it hasn't learned any structure, then it's like then it's like not going to really be reactive, right, to any of that stuff. So you have to verify the reconstruction quality by taking one real audio segment, passing it through the encoder or decoder, and listening to a reconstructed output. If it sounds anything like the input, your VAE is at least partially trained. So let's go back and try that. All right. Okay, so let's do some debug before we give up on this model. Another thing that I noticed is that it was really kind of, it was really quite slow. So to generate 10 seconds of audio, I think it took about 10 seconds. In fact, let's just see. Let's just do this on inference. Let's go import. Let's have every import. Some people like to put imports on the same line. I do sometimes, you know, if stuff goes together, right? Or I put all of like the basic system imports on the same line. But the only problem with that is that if you're copying and pasting imports from different places, then you end up having to do more work, more typing, copying and pasting, and you have more margin of error possibility. So, okie doke. So let's take a look at this. We've got generate audio. So our generate audio function. We're not going to put this inside of the generate audio function. We're just going to say start st equals to time, and fin is equal to time minus start. Okay, and print fin. So now we should be able to see how many seconds it took to generate 10 seconds of audio. And let's see if our model at 128 hidden parameters. Okay, so great. It only took 7.6 seconds to generate 10 seconds of audio. That is perfect because that means that we have a little bit left over. We've got like 2.4 or 2.3, you know, 8, blah, 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 2.385, let's just say, okay? So we have 2.385 seconds to extra on top of 10 seconds. So we're running it at 76th, no, sorry, not a 76, we're running at 76 hundredths. But let's just say we're running at 0.67, or what's the inverse of that? Ooh. .7615. So we're running at an extra 30%, 31% of overhead time that we have. So this is actually good. Like, this makes me think, is if I can get it to generate something that's not just a very stupid sample and figure out like, okay, this is actually working, then I can start to look at, okay, because like I feel like I haven't even really given this a chance yet before I'm thinking about moving on. So let's, like, moving on to a different architecture is what I mean. So let's just go ahead and say, all right, do some debug before we give up on this model. We need to so we're going to be checking the VAE, and then and verifying reconstruction. Make me a test.py file script that tests for the different cases. We need optics on this that can help us figure out what is going on, given most possible scenarios. I mean, this is more of a higher level explanation. Like when I say we need optics, that's very like sort of like CTO, or no, sorry, executive level C-suite request. So if you break down your request into like, am I requesting this as like a C-suite person in this fake company where a programmer is writing stuff for me that's an AI, or am I requesting it as a senior developer, or am I requesting it as the project manager? And that goes back to our whole like meta agent thing, to make an agent that can set up a team of agents for solving a specific problem, and then set up their scripts. But we'll get to that. Let's first get through this, because this thing for me is more of a challenge than the other thing, because it deals with stuff that I've been interacting with less over the last couple years. Whereas agents and stuff like that, like using the LLMs, using these models, these trained models, and prompting them has been mainly my focus this last, like, say 18 months. Okay, so what do we get? Below is a test script, single file test. Pass one audio file and the script will load the file, run it through the VAE, save the reconstructed audio, print reconstruction metrics, L1, MSE, or STFT based off if you choose. Okay. Pass an index file, that's good. So we're actually, remember when I said we need optics? This is the optics thing. The reconstruction metrics, right? Instead of just listening to the reconstructed audio with our ear, we can get an actual metric on like what's going on. And the nice thing about getting a programmatic metric is if you can understand how to interpret it, then you can write a piece of code that just uses that as part of the loss function. And then that further enhances like training. It's almost like a meta training. So, okay. Pass an index file with multiple audio segments, similar to train index, and the script will randomly sample or iterate through a few times, reconstruct each file, save or print some reconstruction metrics. This way you get optics on the VAE is doing, and you can see if it's producing near silent signals, random noise, or something close to the original audio. Okay, I'm gonna turn it way down when I'm testing this, so let's just copy the code, and let's just go over to the test system. Okay, so this is gonna be my test script. Where's my, oh, BAP. Test.py. Okay. All right, and I feel like I've got to put in here these comments that were given for further down, the usage examples. Single file. Single file, everybody, single file. Bap. Backticks, remember, backticks. Everything should be able to be turned into a markdown file, which means that it would have formatting to be turned into a document and shit like that. So let's go like this, single file. This is gonna be a header 2. Okay. All right, loads the example wave, blah, 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 blah. Okay, test multiple files from an index. Now, if I were to actually copy all of this stuff, now the problem with these backticks is that, yeah, if I was to copy all this back into as my code, I'd have to copy from here and leave out the usage examples, but that's fine. Multiple files from an index, because we could just add this to the README, for instance. And I could take my time right now to add it to the README, or I could just tell my little O1 junior developer to do it for me. Okay, which one was this? I wasn't even paying attention to my own process. I was talking while I was sifting through things. Deterministic mode, no random sampling. If you want to see how the model reconstructs without sampling from logvar, just passes mu to the decoder, skipping the random epsilon from sample latent. Okay. So notes and tips. Spectral loss. The provided compute spectral loss is a simple STFT-based magnitude difference. It's not the same as multi-scale STFT. This has to do with a Fourier transform or perceptual loss, but which means you're going to be seeing like a spectrum over quite possibly what the difference, the loss. So, yeah, so STFT is not actually going to be this is spectral loss. Okay, that's cool. That's a nice function. Actually, let's take a look at that. Let's take a look at this spectral loss function. That's pretty dope. Reconstruct, single audio, compute spectral loss. So compute a naive spectral difference via STFT magnitude. So the batch, and then it's just going to be one T waveforms on the same device. Return average L1 difference of STFT magnitudes, a small proxy. Hyperparameters for STFT. Okay, so the Fourier transform is going to have 1024 buckets. Hop length. Okay, let's just look up. Yay, Reddit. That's me on Reddit. Let's just look up STFT. Short time Fourier transform. Oh, look at that. So this is actually a spectrogram visualizing the results of an STFT of the words 19th century. Here, frequencies are shown increasing up the vertical axis and the time on the horizontal axis. The legend to the right shows that the color intensity increases with the density. So what we're doing is we're giving it a spectrogram. A spectrogram. A Fourier-related transform used to determine the sinusoidal frequency and the phase content of local sections of a signal as it changes over time. So that's great. All right, this is my source content for that NKOTB LSTM. All right, so essentially we're using we're using step 2. We haven't got to step 3 yet. So let's go back to our code. Back to the coattail. Alrighty, so this is our last final non-deterministic example. Let's copy the non-deterministic example. I'm not quite sure how the model reconstructs without sampling from logvar. Okay, we're gonna have to see what logvar actually is. Non-logvar, because we didn't read. We're just like super skimming over this because we're assuming that we understand a decent amount, enough to mess with all this stuff, enough to get into it. That's the other thing is like, this would be a specific form of like edge learning, right? You take what's on the edge of, you don't look into. Here, let's go with another diagram. Yeah. Okay. So you've got like this, right? This is known. Okay? This is in the center. And then beyond that, I'm going to send it to the back. Beyond that, you've got unknown. Let's make it bigger so that it just pops into the thing. And this is talking to learning frustrum. Efficient learning frustrum. Efficient learning frustrum. And let's just say this is like pointing to yeah. So the efficient learning frustrum is like, that's okay. This is where you should be talking to ChatGPT along the circumference of the known circle, since it's inside of the known circle. And these are obviously, okay, if you think about it, these are like circles, which they are. There can be a small difference, right? So this right here would be, this would be a long relationship, right? That relationship is very big. So big diff, okay? Whereas if you were to draw a line like from here to there, you got small diff, okay? So you can either learn here from you can try to bridge this gap, okay? And let's say that this is the actual, so like the surface of your known what you know as compared to everything else of what you don't know, and trying to get to a point on the surface of the unknown. Now, technically the unknown is infinite, so you can never get to the surface of the unknown. But think about it like not like an absolute infinity, but like an infinity in which you take further steps. So let's just go, so the difference, so like how to get from here, let's just see if we can make this a straight line. So here's the frustrum of like, because like you can go around all the stuff that you know all day. Whoa, I'm just hanging out infinitely inside of this known space, right? But then every once in a while you're like, bap, I'm gonna pop out and bubble out to like something. I'm gonna go onto this frustrum, onto the surface of the known thing, and then I'm gonna like try to take steps to get to the surface of the unknown, which is like the ultimate knowledge of a thing, right? The ultimate knowledge of, so some things are a big difference, some things are a small difference. And then you've got like, oh, what are these? Oh. Okay. I mean, I could just pop these in here. So let's say you take your first step, okay? Yeah, give me this shift, use shift. Let's say you take your first step and it gets you there. But then you take your second step and it only gets you halfway again. And then you take your third step and it only gets you halfway again. You notice that no matter how many steps you take and no matter how big the steps are, as long as there's a decay, which you could call diminishing returns, right? So the first time you're like, oh shit, this is like a whole new world to me. I'm Princess Jasmine in Aladdin, right? But the thing is that you're not like you're not actually ever gonna get to the edge of the unknown, because the only edge of the unknown that you can ever know is where it intersects with the things that you know. Otherwise, it's completely out of your. You don't even realize it exists. And there's so many things in this universe that are like that. You know, you just don't. Oh, it's not giving me. You want to snap, don't you? Stop snapping. Oh, there we go. Alt. So I could just keep going and taking more and more steps, but I will never finally get to the end. I will just get closer and closer and closer and closer and closer, but it's eventually going to stop. Like, eventually at this resolution, we're going to stop being able to see the difference between these lines. Like, even if I zoom out, you can see they just start to become like closer and closer together, just become one line. So essentially, this is where you need to be talking to ChatGPT. And these are the types of strides that you can make. You can't, unless you just continue the conversation along with ChatGPT, you can take another stride, you can take another stride, you can take another stride. You will never get to some final thing, right? You can finalize a project, that's great, but you'll never get to finalize your experience of knowledge. That won't finish until you're dead. And even then, if you think beyond the individualist idea, you know, that knowledge will continue on. If you pass that knowledge down, then this will continue, even though you do not continue. Anyway, all right, I'm done with my sidestep here. Okay, let's get back to code. Let's do it. Let's go. All right, this is the non-log var. What happens? Do I still have the code here? Oh, snap. Okay. All right, so let's try this one. Copy. Paste. And let's go, look in my examples folder. Samples. My data. Which one sounds good? "24 seconds in," because I'm doing 2. All right, a little bit of drum, a little bit of low guitar. Let's go one like further in. Oh man, that's perfect. If you cut up space oddity by 2 seconds each sample, on the 43rd sample, it will say just perfectly cut Major Tom. Oh, that's just some numerology shit right there. Really interesting, but not useful. Space oddity 43. Let's copy that. Copy that. Paste. Okay. The 10th, we're going to use the 100th epoch here. Mode single, audio, data 01, space odyssey. I'm probably going to have to put this into quotes. VA recon debug. Okay. Did I get? Oh, reconstruction saved. Okay, so also here is my spectral allometrics. So the mean square error loss is actually, so it could just be we're using the absolute wrong loss function for this, because look at this. Our spectral loss is pretty high. That's 3.1%. That's like, we'll see. That's not close. So let's see if it can just reconstruct directly its thing. We're not going to rename that. Okay. VA recon debug. Okay. Here, first let's open up VLC. And let's turn the volume down, down, down. Just in case. What? It reconstructed it. Whoa, okay, that worked. Okay. Oh. Wait a minute. Let's put these two things next to each other in a playlist. I'm not feeling namey right now. Bloop. Okay, so we're putting that in bloop, and then we're gonna go take the data from Space Oddity 43. So by the way, a 2-second clip will not get me a copyright strike. Was this the reason I chose it? I do not know. It's just synchronicity. It's just synchronicity. All right. Alrighty. Let's put both of you in a little VLC. And let's see if we can hear the difference with our dull cow ears. Oh, yeah. Yeah. Wow. Okay, so in the first, I don't know if you heard that, but I heard that in the real one, the strings sound clearer. Yes, and in the VAE reconstructed one, the strings sound less clear. So, cool. Cool. And the other thing is like this pause that I have, it's not something, when I say pause, sorry, you guys don't know what the fuck I'm talking about. So the pause that I have when dealing with all of this stuff that's coming from, like if we go up here to my other, right, how could I greatly reduce the loss on the VAE training? I ask and I blah, 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 and I adjust all this part. I did that last night. So let's do some debug. Okay, so curriculum learning, training with more data, KL weights, beta VAE. So this is actually, I'm thinking that the problem is not in the, it is not in the VAE. It is in the prior, not actually learning. The prior might not be model latent structure. So I was thinking, because there's like this part down here where it's like, you could actually try different architectures. And I was like, oh shit, that's a good idea. Try a different architecture. But I didn't want to give up, like I don't want to give up on this idea because it seems like a very solid architecture. It processes quickly, right? We've seen it does it faster than real time. It's not too much faster than real time, but that is fine with me. So, how do we get this VAE to like do cool shit? Because we can. Oh, what if I wait a minute. OMG's. Okay, let's try to take a piece of music that is not, okay, please do not, let's take something that's like way out of distribution. So can the VAE, no, Eagles is too close. Enya. Let's take something that's fully outside, right? Something like something from Groove Salad. Groove Salad was this Winamp radio station. Yeah, back in the day before we had streaming platforms and before we had what's those? Ugh, jeez. My back. So before we had streaming platforms, we had this Winamp radio. And this was also before we had like a lot of other stuff. But on the internet, you could stream MP3s over this thing, and it was really dope. And if some of you younger listeners or watchers or whatever are thinking, what's an MP3? I mean, okay, maybe you're not thinking that because you've probably studied it, but mostly you've probably never interacted with MP3s because you only use Spotify or whatever's thrown at you as like non-downloadable streaming content. Streaming was the way that they got rid of music piracy for the most part in the mainstream. As you can see, we're pirates over here. Let's go with a very small one. Is there anything here that's like, do I have anything super small? Let's just rename this to test. Oh shit. Sick. Okay, so delete. All right, so you know what? We're just gonna take this. We're gonna do the same thing. We're just gonna do a 2-second sort of a deal, but we're gonna take all this data and the index. Is the index in there? I don't want to star that. Yeah, okay. So we're just gonna rename it to bar data. And we're gonna take, where is our, let's go. Let's go. Data prep. So we're gonna make a new one called test Bowie. And test Bowie, so we have train Bowie, right? Now test Bowie is just gonna have one piece of music in there, okay? And we'll just call it test just to make it, you know. Sorry, DJ Crush. That's DJ Crush right there. Tobida. He's great. But we're only going to hear 2 seconds of his shit, so I don't even have to attribute him. Anyway, the point is. Okay, so we got test Bowie, output dir data. Oh, let's do data test. And we don't have to rename the other thing. Let's just keep it at. Keep on keeping on. It's not rename data. Okay. Okay, cool. So now we have our music, our thingy samples in test Bowie. So this is our music folder. And then we have our Helios folder. All right, data test. Sweet. And we're probably going to be able to get like, oh wow, this was kind of short, but that's fine. Let's just here one. Okay. Okay, let's do test 11. And we're gonna do this again. We're gonna go, let's go back over here. Come on, where'd you go, Helios? Okay. All right, so bloop. VA recon deconstructed. Let's get that reconstructed one. Bloop. Yes, replace it. Wow. So the VAE is actually pretty good. You know, this is correct. This loss, L1 loss is low. That's less than that's 0.2%. A spectral loss is 3, but I can see that. I can see why spectral loss would be less. You know, I could have it output some pretty spectrograms from the STFT, which might be interesting. But let's focus on, I mean, okay. That would be something that I would do just for, okay, so let's just say it looks like it is properly reconstructing the audio from the, using the VAE Epoch 100. Now, here, okay, so here are the, and I confirmed with my human ears that they sound, that the reconstructed very close to the original. Let's give it this output. Oh shit, I forgot to actually, so here's the thing, it's like, where is my ask there? Where is my ask? So next steps, I should have just asked it what, now it's just trying to give me like I wasted a reply from 01 on that. By the way, is there, oh, 03 is not in here. Legacy, GPT-4 is so legacy now. Okay, it's great to hear you're getting your solid reconstructions, blah, blah, blah. See, because then it's like, oh, okay, that's fine, what are you doing? Tune your latent prior. So verify loss decrease. So since the VA is working well, the next major step is to ensure your latent prior also learns meaningful temporal sequences. If your dream mode or audio to audio transformations still sound like a single tone or aren't coherent, it's likely an issue in the prior training rather than the VAE. Tune your latent prior. Verify the loss decrease. Make sure the prior's training loss, MSE on next step prediction in the latent space, actually goes down significantly over epochs. If it stays constant or doesn't drop, it may not be learning. Just like VAE needs more epochs, the prior can also require more than a handful of epochs, sometimes dozens. Adjust, okay, so how do I verify that the prior has learned something? I have a prior checkpoint that is trained on 100 epochs, but I'm still getting that single thing. Can I make a prior test in order the same way we did the VAE? Okay, so I don't even know what the expressiveness is going to be. That's the thing. It doesn't know. It can't hear this, so it can't know what my ears are going to hear. So if you want richer expressiveness, consider a transformer, blah, 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 and latent space, or a more advanced RNN model. You can also experiment with diffusion-based or flow-based priors on the latent priors if you want more complex generative behaviors. I suppose that, you know, this is just going to be, because there was also this idea of using a vocoder, because the vocoders actually work really well, a neural vocoder. So instead of having a latent prior, we could just have neural vocoders. You can consider a vocoder style decoder, yeah, to push fidelity even higher, but we don't need that yet. We don't need a hi-fi GAN to hi-fi it. This might overkill if you're satisfied. I am. So, just to see what it output, and yeah, it was nothing besides that single tone for 10 seconds. So, how do we make sure the prior does know something, and that the bug is not in our code for inference? Okay. Let's see if we can have it code us up a test. Okay. Test the latent prior, much like we test the VAE. Okay. Perfect. Haha. Yep. It's encoding the latent. Unsqueeze it. See, this is great because like, okay, the thing about ChatGPT is if you do, so you might notice on this project, I'm actually doing very little changes myself. I'm just like changing the YAML file. I'm doing a couple things. Code changes, I very rarely touch those myself. Like I added a thing to the test or whatever. But if I were to ask it for the test script over again for the previous test, it would completely ignore any of the changes that I had because this is not connected to my code base. Now, technically, Devin or something like that should be able to take that into account if it's using, for instance, AST or some other way to like turn my code base into a tree, but that's just not, you know, that's neither here nor there because I'm not even using Devin, yo. I ain't trying to get no junior coder on a large code base. So, encode real audio. We converted real audio, so we get into frames, blah, 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 ground truth. Okay. Usage example. Okay, so prior test. Let's just go. Let's just get this done. Prior. Okay. And instead of like grabbing all this, okay, fine. Single file prior test, data set prior test. Okay. I don't think I'm going to be needing to do no data set prior tests, but shit. Too used to hitting shift enter. Okay. Sweet. So you see how, like, since I was talking to it and I gave it examples of like my actual this output right here, why did I give it that example? I didn't explain it at the time, but I mean, partly it was because it needs to see what I'm seeing, but secondly, because it's seeing what I'm seeing, now when it's giving me another example, I don't have to change anything over here. I don't have to go blah, blah, blah. It knows that I'm using VA Epoch 100. It knows that I'm using this file, test11, inside of a thing called data test. So there's nothing that I have to do here. I could just run it because it already understands, quote unquote. It's already in its conditioning that I have. Okay. Let's, all right. Where do we go? right. Okay, it's turning it way down. Okay. So the predicted entire sequence just has, I see. Okay. Look at that loss. That is a lot of loss. That's 30% for the future. I mean, it's essentially, it's just not, it's the highest loss you could get. So high latent MSE means the prior's predicted frames differ significantly from the actual latent frames. Expect the decoded audio to be inaccurate or beep-like. The prior is capturing temporal evolution. The predicted future might sound more like the real future. Check the decoded audio. If you get a beep, see if the MSE is also large. If the MSE is small, but it still sounds weird, you may still want to ensure the latent dimension or decoder can handle the prior's variation well. Well, the MSE is large. Prior loss didn't decrease. If the prior's next step MSE never dropped during training, you're likely seeing a big mismatch. Tiny or oversimplified RN. If the prior's hidden size is too small for the complex data, it may ignore the input entirely and produce a near constant output. Too large or inconsistent data. If the data is very diverse, the prior has trouble modeling everything as a single RNN. You might see poor predictions. With this script, you can confirm that you actually, so here's output. Yeah, MSE is big. And I listened, and the predicted, yeah, this is the part that it can't, it doesn't have ears. Future.wave had a the predicted future.wave was that single tone again, and the predicted entire sequence was sounded like the original for the first second, and then just the high-pitched tone. So most likely we've got a tiny or oversimplified RNN. Our data is diverse, but it sticks to one set of songs by one artist. So very similar frequency patterns, so to speak. Should we one change the architecture of the RNN to include more layers or parameters, and just in case, here's the config YAML again to see what I'm using. All right, so can the architecture, change the architecture of the RNN to include more layers or parameters to completely change the prior model to be something better fit. I don't like this idea just yet because I think we can at least get a pattern out of the RNN as, okay, 3. Okay, so if we're gonna go higher here, like, okay, increase the hidden size, try the hidden size 256 or 512. Change from a single GRU layer to 2 or 3 layers. So let's do this. Let's go git commit am. Oh, wait. First we need to git add test .py and test prior test.py. The rest of it is just extra junk. Okay. Proper testing system. Okay. So now then, we're going to change this latent dimensions 512. We're going to go with 512 latent dimensions. And we're going to change from a single GRU layer to 2 or 3 layers in our inference, in our model. And essentially what I'm going to try to do is just go in. Oh, I realize why I'm using the word essentially so much. Because I'm talking to ChatGPT a lot. And essentially, that's what it always says. Essentially, blah, 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 blah. Essentially, so on and so forth. So it's going to be super weird. Why do I have REPL open? It's going to be super weird to try to, in the future, like people's speaking patterns are going to be changed, and they already are being changed by LLMs, by AI, by chatbots. If you talk to them a lot, it's just like how when you talk with people. I got family in Texas, and when I go to Texas, if I'm there for like a couple of days, I start speaking in the Texan accent. Well, it's not now. That's more like an Arkansas accent. Y'all don't know. Okay. So my Texas family is black, so like it's a black Texan. Anyway. All right. So latent prior, blah 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 blah. Where is our? Oh, that's an inference. Derp. Okay. Train VAE. Where's my GRU? Latent prior. Where is my GRU? GRU, where are you? the okay, wait. Blap, blap. Aha. This is what it's saying. Do that. By the way, I didn't have to do 2 keystrokes there. It could have just been 1. Oh, control question mark. All right, so I mean, we got enough steps in our latent prior to do all this well. So we've got our GRU. We're on this step. GRU. All right, so we've got our GRU, and we got linear, 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 linear. After that, pops it back down to linear spas. Okay. Let's just ask it real quick. All right. Before we submit this, you're using E5 1.2 too low to escape trivial. No, I tried it with E5. Number 2, not a problem. It's doing the same thing for 1E minus 4. So, and I noticed that it might have been overfitting. So perhaps we keep that 1E5, 1E minus 5 for a training go. Also, let's just go over latent prior.py from models. Teacher forcing. Purely next step teacher forcing, it might learn short patterns but fail in fully autoregressive generation. We don't need we're not doing like autoregressive generation, I think. Well, maybe, okay. Sometimes techniques like schedule sampling gradually reduce the teacher forcing ratio, helping the RNN generalize better to free running mode. Okay, Python doesn't have a built-in scheduled sampling, so you'd implement something like if random, teacher forcing ratio is less than teacher forcing ratio, feed the ground truth latent frame, and then feed the predicted frame. If that's too much work at this stage, you can chill check how the RNN is trained. If it's purely teacher forcing, it may produce a beep in dream mode despite lower MSE training. Oh, let's try this first. Okay. So that gets commented, this gets uncommented. Like before we change it. And scheduled sampling or teacher forcing. All right. If the loss plateau is too high, teacher forcing versus your code presumably does teacher forcing for the next step prediction, but inference so autoregressive steps. This is a valid approach for generating new frames from the last gen. Make sure the training loop Okay, so I wanted to integrate the sampler schedule into So I'm gonna wait on the sampling schedule integrated in TrainPy. Here's updated. I'm going to wait. Oh. Your segments are too big, you might otherwise stress the RNN's memory, or it might converge into a trivial situation. Okay. Alright, one thing at a time. I feel like I'm all over the place. So let's bring this back down to 128, just in case. And since we're going to be leaving everything sort of... Let's do one... Okay, -5, that's fine. Okay, so let's grab TrainPy. You know, you might wonder, why am I always putting this in here? Because that's what you gotta do. All right, TrainPy. Oh, little TrainPy. Little cute TrainPy. Training cutie. Get you all trained up. Training is hard. All right, let's see. Taking a look at my channel. I've got my one viewer. Like the one spammer who's probably literally just put up a spam. Oh, TradeQuest. Hey, what up, TradeQuest? Yo. Didn't mean to call you a spammer, dude. No, there was like one guy dropping some like Twitch spam into my stream. 1 hour later, right? Yeah, I don't even watch I'm like super noob at Twitch. So I like have no idea how to get all those cool little like I don't know, I'm like literally using my phone right now to look at chat because I wasn't looking at it before with my phone. So, what brings you to the channel? Yeah, I could just like leave my phone here next to my thing. Oh, sweet. Cool, man. Yeah, the AI agent stuff. So the funniest thing about AI agents is that like, so you got like, okay, so first off, it was something like, when OpenAI was first talking about it, they were like, oh, we got these, oh yeah, Llama 3.2, 13. Oh shit, yeah, dude, I can't run Llama 13B either. I can barely run on my, like literally to run Mistral 7B, you kind of need 7 gigs. So I can run a GGUF version of Mistral 7B on my laptop. Maybe you could try finding like a GGUF version of 13B one that might be able to fit into 16 gig or into I don't know how many gigs you got on your GPU, but I got my VRAM is like at 6 gigs, so I'm kind of limited. But I can definitely do comfy stuff, which is fun. Oh, dude, how is 13B crashing your PC? That's weird. Yeah, I don't know either, man. That's crazy. That's crazy talk. 32 gigs. What? That's 32 gigs of VRAM? Oh my lord. Okay, 16 gigs of VRAM, okay. But 32, yeah, okay, 32 gigs. On this bad boy, I got like 40 gigs or something like that. I did an expansion on my Rogue. Joe Rogan. So I'm rogging it up. Republic of Gamers. My ROG Zephyrus. For those who dare. Joe Rogan up in this. All right, so let's get back to it. Okay, what I was trying to say earlier about like agents and stuff. The idea of an agent is simply the idea of a system prompt that's telling it what to do and then giving it like some ability to make a choice to take an action, right? What is the? I remember when they first started talking about agents, and it had nothing to do with OpenAI. This was just a thing that was on top of what OpenAI was already building, back with like GPT-3. So when GPT-3 came out, everyone was like, "Oh, let's quickly put this into a framework where it can like make choices." And then in the open source community, they started doing this type of stuff. And then all of a sudden, OpenAI saw that and was like, "Oh, we should do that too, but make it closed and make it part of our API." And that's what they did. And so then they started, I think with GPT 3.5 was the first one where they were doing like function calling. It was a whole big thing. OpenAI function calling. Okay, we're December 2024, geez. Okay, that's more a little bit. Did we got anything from like pre-2023? Okay, August. October. Was it really? Oh, it was. This was back then. Okay, this was a year ago. It seems like so much longer ago. So how to call functions with chat models, tools, right? So the thing is that, yeah, they were using the chat completions API at that point, which still existed. The chat completions API, sorry, that exists. But, okay, these guys are doing it with 4.0. So this was back during 4.0. But I feel like this was before 4.0. So it's kind of like this is just showing how to actually do in their little code book parallel function calling. So LangChain and a couple of other guys were doing this first. And what you do is you just send it, you give it tools. So you give it a list of tools. You could say each of these tools is essentially just a function that has some arguments, and you probably need to give it some input as to like what those arguments are going to be. And then all that really does is it just goes into the where am I? So all it really does, I'm trying to find a visual, but like, let's just say this is doing nothing very interesting besides saying, hey, here's the tools that you can get. Like you can essentially do the same exact thing, but on a, I think I was going through this the other day. I made a thing about watching AI poker or something. Let me just, here. So, okay, on any agent, right? So this is it. Think of these guys as agents. These are actually just really long and chained together prompts that are in my own prompting language, which allows me to just have like very specific control over how it generates what it generates and where in the context it is. So in this script, what I'm saying is like here, available actions. I can do any of the following actions, right? Now these don't have arguments, but you know, these might, when you're actually prompting an agent to do a function call. So for me, the most important thing was like, what did they say during the release of function calling? It was like, so we get it to return an actual JSON. It generates a JSON object. And like, do you know how much effort was put into trying to get an LLM to output a proper JSON. Like they had to be big enough, like a GPT-3 or 3.5, in order to actually be able to accurately create working and valid JSON. And so what they did is they just like fed it a whole bunch of instruct stuff with a whole bunch of JSON outputs. And they're like, okay, we got this new model. It's great. It does function calling, and then you can just use it directly in your API, in the API. I mean, that's all well and good, but essentially these guys are just like taking the lowest hanging possible fruits ever, like stuff that the open source community is generating around their models, and then they're encroaching onto the tier 2, which is, for me, that's just not cool. You know, people are using you because you're the biggest and loudest guy on the block, but that's soon coming to an end. Contiguous. Yes, you could say that that's probably going to be non-contiguous. And don't get caught in this cycle. All right, so yeah, because there's like RL agents too. So if we go to like if we go to here, RL is a whole other thing, right? And RL reinforcement learning, and that's been used. Oh, exactly. Paying API is just dumb anyway. I mean, okay, it's cool to be able to use and experiment with like the latest and very large models, but at the same time, it's like, you know, why would I just spend all this money? Like the only reason that you know, I can use OpenAI API is because it's being done through my company. So I'm happy for that personally, because I don't have to flip the bill. But it's you know, it's like it's not the coolest. But Progeny is this is a project that I did a while back, 2 years ago. Thanks GitHub. This one is a reinforcement learning, and it uses Andre Karpathy's Reinforce.js. I just renamed it to RLJS because I'm lazy. Okay, so this is something that he wrote in like, I think a uni dissertation or something like that. But it works really well. There's like an unimplemented LSTM just floating around in there, because I actually ended up patching this, manually porting this to C++. I don't recommend that, by the way. I mean, unless you have tons of time and you just like want to learn. Probably use an existing RL library. But so this is essentially what it does. Is you got this guy's a prey. The predators are the bigger ones with the there's a predator. Okay, so right now with reinforcement learning, what happens is you've got this thing called the greedy. So it is a balance between taking random actions, okay, and using the experience that you've gained from getting good rewards and your learned policy to figure out the best way to get more rewards, right? So that's all reinforcement learning is. It's kind of like everybody understands reinforcement learning because we all kind of do it ourselves. That's how we learn, kind of, you know? So these guys, obviously the prey, they get rewards for killing, the predator get rewards for eating prey. The prey, as you can see, some of them are like not fully filled in. That's because their health is low. That's kind of like a way to see their health. And if you just leave this running, what ends up happening is like I can't just leave it running in an open, in a closed tab, but if you open up this URL and then you leave that running for say 2 hours or something like that, maybe an hour, you'll find that there's gonna be like some predators that are like super predators and some prey that are super prey, and you could tell by just hitting the right or left keys on the keyboard and seeing the difference between each one. The lines that it's drawing is like those are the actual other entities that it sees, and then they have a score. So the prey with the highest score is the best prey, and the predator with the highest score is the best predator. and they actually get some moves. They get some really interesting moves. Like, some of them will use like this thing of like, I stay still until whatever, and I try to stay near other prey. Because when they're next to each other, when they group up, they get a special bonus. Their life starts to refill when they're grouped up. So if they learn how to do that, then they can stay alive for a longer period of time and get a better score. Anyway, so that's kind of like what. Expiring in 6 days. Jeez. So essentially, all right, let's go back over here to Helios. That's not Helios. Let's go back to Helios. Oh, didn't want to close that. And no, Jesus. Helios, please, thank you. And let's just make this easy. All right. So, thanks. Yeah, I got plenty of like little goodies in there in my GitHub, because I like lots of different things, and all that stuff is just stuff that I put as open source because they're just experimentations or explorations of mine. On my other GitHub, the LKSAI one, that's my company's GitHub, I'm like the only contributor, but essentially that's like that's more on a more recent level, using the latest stuff. Like for instance, IBIS, it uses the OpenAI API. I could do a whole thing where I just use IBIS and I like play around and make some dumb things, but a lot of these are just different examples of agents, right? Like I think I showed maybe in this other video IBIS a little bit, and then I showed Bashir, and Bashir is obviously a bash guy. He writes bash scripts. So yeah, those are different types of agents, right? And if you can make a meta agent that makes those agents and can code them, like with any node, I think I showed that one in the other video too. Then you've essentially got this like meta programming system almost, half generated, half programmed, or doing whatever it is that you want to do. But right now, like coding agents is a bit, it's a bit touch and go. And you kind of have to the human has to be there to hook them up to stuff and do other things like this. So if you could have an agent that's just really good at setting up other agents, then that could save the human a lot of time, I think. The human being me. All right. Okay, so we got our config train prior only. Let's go back to our chat. Oh, what happened? What happened, Helios? Jeez. What's going on with you, OpenAI? Why'd you... All right. Okay, I don't want to do any potential tricks. Key changes, teacher forcing ratio. Okay, so this is our new train that it coded up for us. Or wait, this is just the train prior. So example teacher forcing schedule, aka scheduled sampling integrating a current train prior loop. The essential idea is to gradually reduce the teacher forcing ratio over epochs. That's kind of what happens with that RL. That's why I talked about that. A Twitter cat that, okay, so that like it posts tweets on Twitter or whatever and then breeds other cats. That's kind of cool. Like essentially you want to just do like this whole thing where you're generating images of cats, yeah? Or possibly video if you're using some sort of a, I don't know. And the cat's also going to be like having tweets or something? Is that what's going on? So like there's going to be different breeds of cats, and they're like going to act in different ways, and that's why they're going to be Twitter agents. Yes, it sounds so cute. Like, dude, I don't know if you were on the very beginning of the stream or whatever, but I feel it's worth showing again. My cat figuring out how to turn off the water. She loves water. She's a water cat. Oh, no, that's not the thing. That doesn't do it. All right, yes, okay, it's still on. There we go. Haha, you did it. Yeah. Now the funny thing about that video is that it's like framed to look like the cat's trying to figure out how to turn the water off, but actually she's just like trying to figure out a way to go play with the water. She's kind of being like curious or whatever, and she's trying to figure out like to position her body on the sink or something to properly play with the like to get the right angle to catch the water. I think she's trying to catch it or something. And then she went over it and she turned it off, but then she realized that she turned it off. That's what the actual, like, the video looks like she's trying to turn it off, and then she does. But in actuality, she's just playing. But it's a good one though. Okay, so let's just do another git commit. Stuff. I don't know what to call this one. All right, we'll push that, and then we're just gonna go into train bap. Ooh, it is. Oh, right. It's just giving me derp. Okay, it's just giving me the priors. This function. So if I were to take this function, let's just put it through our diff again. Diff. Okay, so this is the that's the one. That's the changed one, so to speak, and this is our original one. Okay, teacher forcing schedule from random, import random, total prior epochs for epoch in, range total prior epochs. Okay, it just made this a little cleaner. Total loss, teacher forcing ratio, this is where that adds that in, and the rest of this is the same. Input sequence T1 latent dim. Okay. RNN forward for a single step. Decide if we use ground truth or predicted for the next step. Predicted frames is a list of wait. Okay. All right, I'm definitely gonna have to train this on our thing. So I'm not gonna be using Bowie because I don't want to be uploading like Bowie samples to Google. I mean, I know they don't care and they don't spy on me or something, but it's just you know, I'm lazy. I'd rather just point to something instead of hooking up my Google Drive. So, okay. This all looks good. Epoch plus one, total prior epochs. Okay, because it just uses total. So it's actually made its code more efficient in this case, which is nice, among other things. So let's just go ahead and that ended on line 193. I use this a lot from pasting in stuff. Just figure out where it ended. Okay, yeah, it definitely added like 40 lines of code to this. 38. Okay. partial teacher forcing or added scheduled sampling. Hybrid teacher forcing. Yeah, 47 insertions, okay. Well, paint me wrong. Okay, doke. Let's do it. Let's do this. And hopefully, I think on this one, like, okay, remember, I'm not training an agent here. I'm just training a model that can do real-time audio reconstruction, and it could also do audio to audio real-time, and it can also do just dreaming up audio randomly. So and I think in the future I might be able to do something like add guidance or whatever. All right, we're getting to the training part. It's training the VAE. It's gonna do 100 epochs. And I think on 100 epochs it's good because we got that VAE to be, it sounded really great when we listened to it before. So that's just gonna be, that's kind of boring. Let's, in the meanwhile, let's check out some cool stuff. Guys get to be part of my intimate, this is the stuff that YouTube shows me thing. This is the output of my YouTube algorithm. The disturbing rabbit hole behind adult content, really? The wrong way to learn. Build something small. Totally out of context. The new rich. You know, he's always talking about the new rich. I mean, he's a great guy. AGI, okay. I think that this is total. The idea of the AGI countdown, it's kind of like what I was saying before here. So this is why none of that shit, the countdown to AGI and all that stuff makes no sense, okay? No absolute sense. It's just full on 100% grifters, okay? All they're doing is trying to get you to use their API. So this is what we know. And this is everything that we don't know. Technically, the limits, there is no limit on what you don't know. That's the only thing that's unlimited in this world, is how much you don't know. So right, these guys are like, oh snap, what did you do, YouTube? Why did you re me up? Come on now, that's no fun. Where'd my video go? Oh, geez. Work cooked. Trump's Great Depression. Sounds like it's gonna be a great time. Yeah, totally, dude. Singularity. But I personally think that we have like a long way to go to get to singularity, because was this game anti-white? Come on now. No, I think we have a long way to go to get to the actual singularity, right? Because we still haven't gotten necessarily to AI. Like, this is what I think. I think that okay, AI, like AGI, right? That sits on this. Because why? Because you could just keep changing the goalposts. It's a little bit further on. It's not what we said. If there's a negative criticism of our model, oh, it's not AGI, because we haven't gotten there yet. But we do have AGI coming, by the way. It is coming. There's only so much that a CEO can say, really. I mean, I kind of feel sorry for Sam Altman because I have a CEO, and you know, he's not a technical guy, but he does his best to try and explain things. Technical things, like he knows exactly what he's talking about, but really he relies on the CTO and the rest of his team to know what they're talking about. And that's the same with every CEO. I mean, the best CEO in the world, and I'm not saying best by a measure of a good person, I'm saying best by a measure of doing the CEO job, was Steve Jobs. You know, people still think that he invented the iPhone. Elon Musk is pretty good at it, but he's definitely not a Steve Jobs. He's like a well, he's like a mid. He's a middling Steve Jobs. So what we know is that statistical algorithms can output interesting, pretty stuff that seems like it's human. We also know that humans can get tricked into thinking that something is human if it acts enough like a human in text, or makes human expressions, or talks slang, or just says something that they don't expect, because they have this like unknown effect. They're taking this big leap from like, oh shit, computers don't know anything, they're dumb, to like, oh man, a computer could talk to me and it could chat to me and stuff. But that's just all it has to do with human perception. It has nothing to do with actually like what intelligent, because like what is intelligence? That has not been able to be figured out. Like all these companies have to come up with their own idea of what AGI is. They have their own benchmarks. They have their own, they're defining what the term means while they're saying that they're getting to it. It's kind of like taking your, I don't know, anything. Like it's just cheating, basically. They're just cheating. They're saying, oh, it's like playing a game with somebody, and then you're the one who could make the rules, so you could constantly change the rules so that you always win. Was AGI achieved internally at OpenAI? Well, the answer to that question is yes, because they're the ones who define what AGI is, so they could say whatever it is they want, right? One of the oldest tricks in the book. Whoever has the gold makes the rules, basically. But essentially, OpenAI doesn't have the gold. They have no moat. They have nothing. They're just a popular company who's losing $700,000 a day. What was it? $700,000 a day? $700K to run GPT. Dude, how do they not run out of money? Okay, if you think about it, $700,000. Okay, these guys had an investment. These guys had an investment of, okay, behind OpenAI's historic $6.6 billion funding round. So let's just take one round of investment, because this is a $157 billion valuation. So raises 6.6 and is now valued at $157 billion. So they're valued at $157 billion, but that doesn't mean that they have $157 billion. They just got $6.6 billion, and how many employees do they have? Blah, 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 so on and so forth, cap for profit. So let's say that, okay, if they make $3.7 billion in revenue, let's just take that number, right? And they spend $700,000 a day, so 3.7 billion, so 3,700,000. So that's 3.7 million. 3 more zeros on that. Divide that by 700,000. They have, so if you divide that by 365, they make enough money in a year to power all of their GPT stuff for 14 years. So, I mean, that's how they do it. That's how they do it. That Redditor just didn't do the research. I mean, it's a good question. Got plenty of upvotes. But yeah, I mean, they are definitely not losing money, so to speak. They're still getting investment money, and that's just talking about running the thing. I mean, obviously, the rest of this 14 years worth of revenues has to go into all the other shit. Yeah, they just long their stock and it's good. It's the same stuff as Tesla. In the beginning, they just long their stock and it's good. It's true. The stupidest thing about back in 2020, everybody kind of went into like these rabbit holes because they're stuck in their house. I'm always like kind of in my house or whatever, so it wasn't too big of a thing for me. But I went down some rabbit holes because like shit was not normal. So, oh shit, I forgot where I was going with that. Whatever. But anyway, all right, let's check back on. Okay, we finished the VAE training. It's just started trading priors. Okay, we got down to 0.6. That's not the best. It started at what? Okay, 22% loss. So it's down to 0.6% loss. Is this even going to show us the epochs and the training of the priors, or like what's going on? And how much RAM are we using? 0.3. We don't even need to use a high RAM system on this, so GPU RAM 0.3 out of 15 gigs. Yeah, that's about what it was using on mine, about 300 megs of RAM. So like that's the other cool thing about this is like I want this to be running on my laptop, and I want to just be talking and it just be spitting out like random David Bowie sounding samples roughly. That sound exactly like my voice, but David Bowie eyes, but if my voice was a David Bowie song. This is a little bit alarming to me right here, this part, because it would normally put out, like if I look over here, oh, that's what I was saying. Yeah, sorry, I read your trade quest, I read your thing again. It said, yeah, same stuff as along, okay, so the stupidest thing about what I learned that year was that money is such a game. Such a game. If you are not investing in anything, then you're losing on the game. You're losing. And it doesn't matter what you invest in as long as it's going to be like long term, it's going to be positive. And then you've got that saved and you've got more coming in from it and whatever. Used to be savings accounts and shit back in the day when banks actually gave you positive interest. But in the end, banks just, they just do the same exact thing with your money. If you're not moving your money around, if it's just sitting somewhere, then it's not making money for you, then you're playing money wrong. That's what I learned. Okay. But, right. Okay, so you see this output, and it didn't take that long to output that. I feel like somehow this got stuck, but it's not putting out anything. Let's give it a little bit more. Let's give it time to cook. Let's let them cook. Let them cook. You see, it got all the way down to like 4 though, on 100, on my priors final, right? Maybe I should just, since I'm not doing a bigger thing, maybe I should just go on this. Maybe I should just be running. I don't know. Oh, that's the thing. Like, because I'm doing OBS or whatever, I'm not sure if that's going to be making my stream glitch. But I definitely want to know what's up with this priors training thing, so let's just go ahead and just do something I could just stop. By the way, TradeQuest, you're literally the first person to ever chat with me on a stream. So, congratulations. I wish I prepared some sort of a thing for the community to give you like a little present. I don't know what to give you though. Happy holidays. Yeah. So like, yeah, because the reason I said that like spam comment was because literally the only other chat that I've ever seen from anybody on Twitch so far is just a little spam bot trying to spam me up. spam up my channel, spam my chan. So yeah, thanks a lot, man. That's or man or woman, not quite sure, but thank you, person. It was amazing. I feel great. I'm really happy. That made my day. All right, so yeah, nice. Insta follow. Yeah, thanks, man. Yeah, there's not so many people doing this type of stuff on Twitch. That's definitely what I've found is like, it's really like kind of not the thing to search for on Twitch. You're probably searching for like a video game or something. But the only reason I'm even on here is because like the Primogen stuff. Because I saw him on YouTube and he's starting to get into YouTube a lot now, and I wanted to just kind of like be part of his chat or something. And I think literally like every single video that I've made so far, I've mentioned him at some point, which is kind of like, yeah, I gotta get off his jock or whatever. But it's true that's why I'm here, and I think it's great that I'm now finally being able to interact with somebody. I don't feel alone anymore. So yeah, thanks, man. Big ups. I'll try and figure out some stuff to like, I don't know. There's like this whole thing in the creator backend which gives you like, you know, gifts and blah and so on. I haven't even got started on any of that stuff because it's like, how am I gonna monetize this? I don't know. But maybe, I don't know. We'll see. If there's enough people out there like you, yeah, get it. Straight flowing. Oh, there's this whole thing I did about freestyle. Okay, I was talking about freestyle rap, right? Like, part of my growing up, being raised, I was raised partly in Detroit, and that was like I'm mixed, so I'm like I'm brown, part white, part black, and like inside of that there's a whole bunch of detail, but in the States like everything is very, well, you know, black and white. So long story short, when I was in Detroit, I learned how to beatbox and like freestyle rap and stuff, and that was actually like one of the best experiences, I think, freestyle rapping, because it really forced me to focus on like the thoughts that are coming up in my mind in real time, and then just accepting those as like this is, and not having to worry about like what people think of me or what I'm saying, like double. Oh, perfect stream skill. Damn. Yeah, it is a perfect stream skill. Like that little Frost rap battle that I had was pretty fun. It reminded me of that too. And it's true. It's true. Oh my gosh, I think this is I think that's dead. Nothing happened. Man, what the junk. All right, let's back up my prior, and I'm gonna try data. No, not data. Oh god, checkpoints. There we go. Okay, we'll just because it could very well be that my prior is actually working, because there's still a little bit of a confusion matrix going on over here. Bloop 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 blah bloop bloop. Let's copy that. And I don't like that nomenclature. I'll just put it. There we go. Okay. So, oh, I already did that. All right. Commit prior Python prior test train prior only. Okay. Okay, so I'm gonna try this last time. I mean, it got all the way down pretty low, but it looks like we should only need to train it down 30 30 steps or something, 34. If we can get to, let's do 40 epochs. Get it in the 0.1% loss ratio, rate. So we're probably gonna have to change this config. So just give it prior epochs, let's just do 40. All right. Let's hope this doesn't freeze my stream. Go. All right. Yeah, I'm probably gonna take a little break here too. After this. But snap, dude, the same thing is happening. What the? Oh, is it not outputting? I think that's what's going on. I think it's just not outputting the priors. Where was it? Result equals grew. Result equals this. All right. 9251. So this was in the middle of train prior. Oh, dang. Nice. Yeah, okay. Yeah, I'm still going to be here. In fact, I'm going to go get something to roll up. Okay, looks like we've reached an impasse in our training. It should only be one batch sequence. Derp. All right, hold on. In the meanwhile, let's just, I'll be right back. Wait, I'll put this on VLC. It mows. Reindeer. Him names. Yeah. All right, I'll be right back.
that banana with a greasy black pea. You're a monster, Mr. Grinch, your heart's an empty hole. You're a foul one, Mr. Grinch, your brain is full of spiders, you've got garlic in your soul, Mr. Grinch. I wouldn't touch you with a 39.5-foot pole. You're a vile one, Mr. Grinch. You have termites in your smile. You nauseate me, Mr. Grinch. You're a nasty, wasty skunk. Your heart is full of unwashed socks. Your soul is full of gunk, Mr. Grinch. The three words that best describe you are as follows, and I quote: stink, stank, stunk. You're a rotter, Mr. Grinch. You're the king of sinful socks. Your heart's a dead tomato splotched with moldy purple spots, Mr. Grinch. Your soul is an appalling dump heap, overflowing with the most disgraceful assortment of deplorable rubbish imaginable, mangled up in tangled up You're a mean one, Mr. Grinch. You really are a he.
Jingle bell, jingle bell rock. Jingle bells swing and jingle bells ring. Snowing and blowing, that bushels of fun. Now the jingle hop has begun. Jingle bell, jingle bell rock. Jingle bells time and jingle bell time. Dancing and prancing in Jingle Bell Square. In the frosty air.
Yeah, that's so weird. Like, every second time that I start my stream,
Rocking around Christmas tree at the Christmas party hop. Mistletoe hung where you can't see, and the couple tries to stop. Rocking around the Christmas tree, let the Christmas spirit ring. Later we'll have some pumpkin pie and we'll do some caroling. Rocking around, 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 rocking, 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 rocking up, 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 rocking up, 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 rocking around. Rocking around, you will get a little feeling when you hear voices sing.
okay. So weird.
Bells with boughs of holly,
I can't figure it out. Fuck it.
Christmas tree, have a happy.
Just not gonna put any music. Damn. Alright. Okay. Oh my gosh. It finished! It finished! That's how long it takes to do one epoch? What is my configurement on? Configuring. Oh, because it's doing like this, okay. Because it's doing this thing where it's not doing teacher forcing. But let's just take a look at, let's just take a look at our YAML. Yammy. Come on, Yammy. What you got for me's? Okay, 128 latent dim. Okay. Oh, we are doing a 100 epochs for prior on learning. Okay, this is gonna be a moment. Going to be a moment. And I might have to get going because essentially I got some work coming in, I think. Yep. Yeah, I'm gonna get going. This is a good point to stop anyway because this is like, you know, there's like lots of there's lots of training to do. I guess we'll just leave this running and see what happens. Like, it's probably gonna eat up my credits, but I don't care. 205 compute units. I'm using 1.66 per hour. It just took one epoch, like, God knows how long. Like 30 minutes or something. So you multiply that by 100, 3,000 minutes. $50 hours. Okay. I'll be back in 50 hours-ish. Couple of days. I mean, we'll see what happens, right? This is going to be interesting. We can get onto other stuff in these next days and just let this, you know, eat through my credits. $50 times 1.66. 83 credits. That's not so bad. This is where I'm wishing I would have used well, okay, just because it has more VRAM doesn't mean it's faster. Yeah, okay, cool. Well, we'll see what happens with this. Until then, until next time, enjoy.